Okay, here we are outside, and I wanted to go through with you how we got the data that we used in the radiation lab. So in the radiation lab, we're interested in looking at the net radiation, how much radiation is present in our environment to heat things up or evaporate water. So what are the components of the radiation balance? Well, there's the incoming sunlight and the outgoing sunlight. Outgoing sunlight is that's what's reflected off the surfaces. So as you can see around me, we've got different color surfaces, grass, concrete, some landscaping material. These are all going to reflect a different percentage of the incoming light that comes in for them. So that's going to be the shortwave radiation. And that's going to be in table 1, column 1 and column 2. So let's start out measuring that. So these numbers are going to be different than the numbers in your lab. I just wanted to give you a comparison. So the sunlight varies as there's clouds going by. So we've got to measure the incoming sunlight. Let's do it over this landscaping material. And we'll see what we've got here. 175 watts per meter squared. And then to measure the outgoing radiation, we're going to have to see how much is reflected. So I'm going to turn this pyranometer upside down to measure the light coming out. And so we have here 27 watts per meter squared. All right, let's just move this instrument over to the concrete, which is much brighter and more reflective. Now I'm going to remeasure the incoming sunlight because the clouds are moving across the sun. So now I get 153 watts per meter squared. And then to measure the reflected amount, 40 watts per meter squared. So as you can see, there's a lot more outgoing energy, shortwave energy, coming off the concrete because the concrete reflects a lot. We'll do one more over here on the grass. Although this is a little bit under the tree, let's check it. Incoming, we get 128 watts per meter squared. That's because there's a big dark cloud and the sun is blocked by the tree a little bit as well. Outgoing, 37 watts per meter squared. So the grass is a little bit darker than the concrete. It's not reflecting as much light. So that's the shortwave energy that comes in and goes out. We'll want to subtract the outgoing from the incoming to let us know how much shortwave energy remains. The second part of the energy balance equation is the long wave radiation. That's the radiation that's emitted as heat from the Earth. It's also emitted as heat from the sky because the sky is made of matter, gases, and water droplets and ice crystals, and they have a temperature. So we're going to use a pyrometer to measure the temperature of the sky. And then we'll use Stefan Boltzmann's equation to calculate how much energy is coming from a sky at that temperature. So I just simply point my pyrometer up to the sky and measure it, and I get 24.4 degrees Celsius. So we will put that in table 2, and then we'll have to convert that to Kelvin. We're just going to use one number because the heat from the sky doesn't fluctuate like the light from the sky does, right? The clouds move, but they're not really changing the amount of energy coming in the long wave portion of the spectrum. So finally, what we need to do is measure the temperature of the outgoing surfaces. So first we're going to measure the landscape material. That is at 30 degrees Celsius. Now that was absorbing more light, so we'd expect that to be warmer. How about the concrete? The concrete, 32.8 degrees Celsius, cooler than the landscape material. But then finally we've got, actually I'm not sure, I can't remember what the other one was, but I'll double check that. Finally we've got the grass. The grass comes at 30.2 degrees Celsius. That would be a little bit cooler. It's not going to be emitting as much heat, partially because it's shaded. Okay, that's it.